Hello students, now we can see the VI characteristics of the power BJT. So previous class we have gone through the structure of the power BJT. Now you can see here all the diagrams, that is structure of the power BJT. So here this is a structure of power BJT. These two are the symbols of the power BJT, and the VI characteristics of the power BJT is this one. Now we will move to the VI characteristics of the power BJT. So VI indicates it is voltage and current of the power BJT. So what actually happens after giving the voltage, what you are going to get the current. So we know there are the total 3 terminals, that is called as a collector, emitter and base. By using these 3 terminals, we are going to apply a voltage to 2 terminals of the BJT, that is collector and emitter. Voltage across collector and emitter is mentioned as a VCE. So this is here, it is shown. VCE indicates it is voltage across the collector and emitter. We are applying a small amount of the voltage to the collector and emitter, and we are going to check what current, that is a collector current, so how much is going to be produced, or it is going to be come from the power BJT. So the axis consists the VCE, that is voltage across collector and emitter, and the y-axis, that is consists the collector current. This is the IC. This is the y-axis, that is consists the collector current, and we are observing the graph of this, that is a VI characteristics, voltage and current characteristics of the power BJT. So now you can see here there is a graph which is having number of lines, curves over here. So here I can check the collector current for different base currents which I am applying at a different time. So now the base current can be mentioned as VB0, VB1, VB2, sorry, it is IB0, IB1, IB2, IB3, IB4 and IB5, etc. So here this much is sufficient. So what I am doing here, when you want to check the current characteristics when you are applying the voltage, so base current you need to be changed. So you have to start with the initial value, that is 0. So when you are applying the base current 0, what changes, what current is coming across the collector, and when you are going to slightly increase the base current one by one, step by step, what changes the collector current is again coming, we are going to observe. Actually here we can see the 3 regions, that is 4 regions. One is a cutoff region, that is a quasi saturation region, hard saturation region. So these regions, so again last one is an active region. So these regions are including different voltage what we are applying and what current is coming. So it is indicating in these regions. So first one, I can show you what is a quasi saturation and hard saturation region. So you can observe here I have shown the arrow mark. This is quasi saturation and this is hard saturation. So when these situations are going to be occur, so in the quasi saturation and hard saturation, the base drive is applied, hence the transistor is on and the collector current flows depending upon the load. So what is the meaning of this? In the quasi saturation and hard saturation, the base drive is applied, hence the transistor is on and collector current flows depending upon the load. So when I can show you on the symbol here, base current you are going to apply, you are already given collector and emitter voltage, and when you start giving the base current, so at that time it is a sufficient base current which will make your transistor on. It is purely on, current starts flowing. So this is called as a quasi and hard saturation. So now what is next? That is a cutoff region and active region. In the cutoff region, what we can say, both, that is a base and collector and base and emitter, these junctions will be reverse biased. Reverse bias means whenever the voltage you are applied to this collector, emitter and the current, that is a base, so whatever the supply you are giving to the three terminals is reverse biased. The junctions will be reverse biased. That's why the cutoff region comes here at the arrow mark what I am showing. This is a cutoff region. There will be no current flowing in the power BJT when it is in the cutoff region. So your junctions are act as a reverse bias. So when it becomes an active region, so when your collector emitter voltage is a small amount of the voltage you are applied and you start giving a small amount of the base current, it starts with some value, you can choose it. So now I have shown the IB is equal to 0, there is no current. So when you give a small amount of the current, that is I can say IB1, it is a small amount of the current. So at that time what happens, your transistor starts conducting and it gives a current, small amount of it reaches to here and it becomes a constant. So this is amount of the current which is coming when the base current is somewhat equal to IB1. So now it is remains constant. So small amount of the current starts flowing in the collector of the power BJT. So next, when you want to check again the next characteristics, so what happens when the base current is increases? So I'll go to the little bit increasing the base current. So I'll increase again base current. So at that time what happens, again the collector current increases as per that and it maintains constant at like this. So this is how you are going to increase base current of your power BJT. The graphs or curves are going to get like this. So you can see here always how the IB5, IB4, IB3, it is greater and greater, it is mentioned here. So here the base current, how you are going to increase, the curves, the collector current is also going to be increased. So totally depends upon the base current. Base is acting as a controlling current. So when you are decreasing the current of the base, the collector current is also decreasing. When you are increasing the base current, then your collector current is also increasing, and it is having a relation like this. This is a VI characteristics of the power BJT. So next